recording and let me share my screen. Okay. Tell me when you can see my screen.
So we can see your screen.
Okay. Now we will do a quick recap of what we did yesterday and then we get into triangles today. Right? So yesterday we stopped with the triangle, right?
Yes, sir.
So I'll show you a very simple way. Yesterday I showed you the actual derivation right from first principles. I'll show you a much simpler way to do this. Okay. Let's say I
Yes, sir.
have again the same ones x1 y1, x2 y2 and x3 y3. So this time what we'll do is we will straight away go for the triangle ABC itself. Now how do we do that? Triangle ABC is equal to the trapezium ABC DEF. The trapezium ADEB plus trapezium BEFC minus trapezium ADFC. Tell me if you understand this.
Yes, we do.
Trapezium ADEB, which is this one, right?
Right.
Trapezium BEFC, which is this one. This is the whole thing, right?
Yes, sir.
And
Yes.
if I subtract ADFC, that means this part, then what is left?
ABC triangle.
Okay, this is the
Yes.
simplest way of doing this. So that means triangle ABC is area of trapezium, all are half, so I can take half common. ADEB. ADEB means the parallel sides are AD and BE, right?
Yes.
ADEB, right?
Right.
So parallel sides are AD and BE. So what is AD?
AB is x2 minus x1 squared.
AD, no. AD.
Or,
AD is the
oh,
vertical
AD.
distance.
Right. So that would just be the value of
Y1.
y1.
AD is Y1. What is BE?
BE is y2.
Y2. And the distance DE?
X2 minus X1.
X2 minus X1. So this is the first trapezium. The second trapezium is BEFC. So which are the parallel sides?
BE and
A,
CF.
BE and FC. What is BE?
X2.
y2.
Oh, yeah,
Y2.
Y2.
What is FC?
FC is y3.
Y3. What is EF?
That would be x3 minus x2.
X3 minus X2. So this is my second trapezium. And the third trapezium is ADFC. So which are the parallel sides?
AD and
AD.
CF.
AD and FC. What is AD?
It is y1.
Y1. What is FC?
y3.
Y3. And what is the distance between them? DF?
x3 minus x1.
X3 minus X1. So now we just simplify this. This is half Y1 into X2 plus Y1 into minus X1. So that is minus X1 by 1 plus Y2 into X2 plus Y2 into minus X1. So minus X1 Y2 plus Y2 X3 minus X2 Y2 plus X3 Y3 minus Y3 X2 minus of Y1 X3 minus Y1 X1 plus X3 Y3 minus X1 Y3. And then we just simplify this. So we can see that we have minus X1 Y1 here and minus X1 Y1 with a minus sign here will make it plus, right? So we can cancel these two. Okay. And what else will cancel? Y2, X1, Y2. X3,
X3 Y3 and X3 Y3.
X3, Y3 and X3, Y3. Correct. So these two cancels. So now we are left with 8 terms, right? So anything else cancels? Y1, X2, Y1, X2, no. X2, Y2 with X2, Y2. Okay. This also cancels. So we are left with 6 terms. So this becomes, I collect all the Y1 terms. So I have Y1 into X2 and minus X3. Okay?
Yes, sir.
Yes.
Y1 into X2 minus X3 plus Y2. So with Y2 I have a minus X1 and a plus X3. So Y2 into X3 minus X1 plus Y3 into minus X2 and plus X1, because this minus minus will become plus. So Y3 into X1 minus X2. So this is the final form of my expression which we derived yesterday also. And the way to
Yes,
remember
sir.
this is always the Y coordinate will be outside. Okay, and it will multiply with the difference of the X coordinates. Now the logic is you take Y1. So Y1 is here, the first point, right? You take Y1, go to the second point in a clockwise direction. X2 minus X3. That is the first term, correct?
Yes, sir.
Now go to the
Yes.
second point, which is B. Move clockwise, okay? Y2. Then take the next term, X3 minus X1. Y2 into X3 minus X1. Okay? Come to the
Yes.
third term, Y3 into x1 minus x2. y3 into x1 minus x2.
Okay.
Is the logic clear?
Yes, it is.
Shall I repeat this? Okay. I have 3 points. Any 3 points. A, B, C. The coordinates of these points are x1, y1, x2, y2, and x3, y3. So area of triangle will be half of, we take the first point, y coordinate of the first point, which is y1. Okay?
Hmm.
We move
Yep.
clockwise. Go to the second point. Take the x coordinate of that. What is that?
X2.
X2 minus
And subtract
X3.
the third one from it. Next, move to the next point, which is B. Take the y coordinate, y2.
Y2 multiplied
Move
by
clockwise, x3,
X3 minus X1.
x1. Next, come to the C coordinate, C point. Take the y coordinate, y3 into
X1
x1
minus
minus x2.
X2.
Here.
Yes, sir.
So this is the logic. And another way to remember it is just name the points sequentially. So A is closest to my 0 or origin. So A would be x1, y1. B is the next point, which is the second point from the origin. So B would be x2, y2. And C is the farthest point. So C would be x3, y3. So if I take this in the points in this sequence in terms of x1, x2, y3. So the sequence is 1, 2, 3, 2, 3, 1, 3, 1, 2. You can
Yes,
remember it
sir.
either way,
Yeah.
whichever is convenient
Okay.
to you. Okay. I think the
Okay.
first one is easier because that is more logical. You take the first point and start moving clockwise and take the difference of the x coordinates. Then move to the second point, take the y coordinate and take the difference of the other two, and so on. Right?
Right.
Yes, sir.
Is it clear?
Yes, it is.
Yes or no?
Yes,
Yes.
sir.
Okay, great. Okay. Now we will come back to this with problems around triangles, but I just want to cover triangles before that because there are concepts which are involved in order to do those problems. Okay, so we start with triangles. Now, what is a triangle in the very simple terms?
It is a set of three lines that are all connected and make an enclosed space.
Correct. So if I look at the word itself, tri means three, angle means angle. So three angles, right? And three angles means three sides. So this is a
Yes,
triangle.
sir.
Okay. Now, uh, how do we define a triangle? So from the name itself, we understand that there would be three angles and three sides, right?
Right.
Yes, sir.
So how do we? So we have to have some relationship between the sides and the angle so that we can calculate each one of them. Correct?
Yes, sir.
So what is the relationship? What is the first relationship? sum of angles is what?
180 degrees.
Y. Why not 160? Why not 150? Why not 100? Why 180? Can you prove this? That is 180.
Yes, sir. But
Yeah, tell me.
I know it from the angle sum property. First, we draw a line that passes through the A point.
Like this?
No, no.
Then
That is parallel to BC.
parallel to BC through A point.
Yes.
Okay. Like this?
Yes, sir.
Okay, fantastic. Tell me.
Then we name the ends of the two of the line M and N.
Hmm.
So MAB plus A plus BAC plus NAC is equal to 180 degree because it's a linear pair.
Correct.
It's a
Correct. Absolutely true.
then MAN plus AB is equal to ABC because they're alternate angles, and NAC plus ACB are also alternate angles, so they are equal.
Fantastic. Yes.
Therefore, ABC is equal to 180 degree
Fantastic.
if we add them.
Fantastic. Yes. This is the way that you can prove it. Okay. So Kushal, did you get this logic?
Yes. I
So
had another way. It's a bit more visual.
yeah, tell me.
But if you've got two 90-degree angles and three sides,
Hmm.
two of those sides will have to be parallel. And if you do not want them to be parallel and instead go towards each other, they have to be, one of them has to be less than 90 degrees, or two of them have to be less than 90 degrees.
Yeah, absolutely. Or there is another way. You can just cut out a triangular paper like this. You just cut the paper like this. Okay. And you place this part here and this part here, and you'll see that they're exactly matching.
Right. Okay.
Right. That's the simplest way of doing it. And what she just explained is the same thing in a diagrammatic form. So, okay. So, fantastic. So, now we understand why the sum of angle is 90 degree. Okay. What is the next property? What is the next important property? So, that means, okay. So, now we know that if we are given two angles, we can find out the third angle.
Yes, sir.
Sum of angles is 90 degree. What is the next important property?
Angle A plus angle B is greater than angle C, then angle A plus angle C is greater than angle B, and angle B plus angle C is greater than angle A.
Is it always the true? Is it always true?
No, not with an. I'm not sure if it's with the sides or the angles, but if it's a 90-degree angle and the other two are 45 degrees, then they won't be greater.
Correct. So they can be
Greater
greater
than.
than or equal to. Right?
Okay.
They can be greater than or equal to.
Hmm.
Right? So
Right.
sum of two angles will be greater than or equal to the third angle.
Okay.
Hmm.
Correct?
Yes.
Is it true?
Yes.
No, it is not. I have a triangle like this. This is 120. Sum of these two is 60. So is sum of these two greater than the third angle?
Oh, no. It. Yes, if those two were 60 degrees, then it would add up to be. Those two would be greater than the third, but then the three angles wouldn't be 180, which we've already proven to be true. So, therefore, sum of two angles
This
is
is
not
not true.
always greater than or equal
This is
to.
not true. What is true is not sum of two angles. I'll tell you what is true. What is true
Two
is
sides.
the biggest angle plus any other angle is greater than the third angle. This is always true.
Wouldn't it have to be greater than, or actually, no,
It
no,
has to
never
be
mind.
greater than. You look at, you take
Yeah.
example. So the biggest angle can be greater than 90. So let's take 100. Any other angle, let's say the smallest angle is 5, right? So 105 is the third angle is 75. This is one
Right.
case.
Okay.
If this is 90, right? This is let's say 5 or even 1. So 91, right? So this is
Right.
89. You're getting it,
Yes.
right? And if the biggest angle is 60, right? Biggest angle, then the other angles cannot be greater than 60. So it has to be 60 each. You're getting the logic?
Yes.
So the biggest angle plus any other angle will be greater than the third angle. This is true, but not any two angles. What is the third important property? What is the third important property? Can I draw a triangle of sides 10 centimeter, 6 centimeter, and 4 centimeter?
No, you cannot. So, any two of the angles must be greater than the length of the third angle, or
Not angles,
of the
sides.
sides, not angles.
Sum of any two sides is greater than the third side. Only then we will have a triangle.
Yes, sir.
Right.
Right?
Yes.
Correct?
Yes.
Okay, I will come back to this point. There are a lot of things that we need to understand here. So I'll come back to this point after I complete the rest of it. What is the fourth property? So I have to have a relationship between the sides and the angles, right?
So
Right.
this angle,
So
uh,
the largest side must be opposite the greatest angle.
Yeah, largest side is opposite the largest angle. Similarly, smallest side is opposite the smallest angle, right?
Yes, sir.
Yes.
Correct?
Right.
Okay. What else? What else are the properties? We still don't have a way to relate the angles with the sides. We have to somehow relate the angles to the sides. How do we
So
do that?
there's one more property. If we extend BC, then the angle A AC and extend it to the other side by exterior angle property.
Sorry, which angle property?
Exterior angle property.
Yes. What is that?
If we extend BC,
Mm-hmm.
so the angle that is formed outside
Mm-hmm.
will be equal to A plus B, and that will be
Supplementary.
applicable to, yeah.
Correct. Exterior angle is equal to sum of opposite interior angles, right? And why is that?
Because they must add up to 180 overall,
Correct.
so it must be supplementary.
Correct. So this is angle C. So angle C
Hmm.
plus angle A plus angle B is 180, and angle C plus the exterior angle is also 180. So therefore, those two are equal. But
Yes,
we
sir.
still don't have a way to relate the angles with the sides. Unless we are able to do that, we will not be able to calculate, right?
Right.
How do we
Yes,
relate
sir.
the angles to the sides? Okay, so let's look at the triangle ABC. I drop a perpendicular from A on BC at B, right? So
Yes, sir.
I can write the sides in terms of small a, small b, and small c. So if this is angle A, the side opposite to that, which is BC, will be called as small a. If this is angle B, then AC becomes small b. This is the naming convention of a triangle. And AB is small c. Okay?
Okay.
Okay? Any doubts?
Yes,
Yeah.
sir.
So,
No.
what is sine C? What is sine of angle C?
Opposite and hypotenuse. So it would be AD and side B, or side H and side B.
Opposite means
H
H over
over
B,
over B.
right? So
Yes.
we can write H is equal to B sine C, right? Correct?
Right. Yes.
And again in triangle ABD, we can write sine B is H by C. So H can be written as C sine B. Can we do this?
Yes.
This is
Yes.
my angle B. Sine of angle B is opposite, which is AD, over hypotenuse, which is AB. That means H over C. Correct?
Yes.
So from there, I am writing H as C sine B. Right?
Right.
And I have also found H as B sine C. Correct?
Yes.
So therefore, now I am getting some relationship between side and angle. So therefore, equating H, I can write B sine C is equal to C sine B, right?
Yes.
So therefore, B by sine B is equal to C by sine C,
Yes.
right? Now same thing, if I would have dropped a perpendicular from B on AC like this, so using the same logic, we would have been able to establish that A sine C is equal to C sine A. Same logic. Okay?
Right. Yes.
Are you able to follow this?
Yes.
Yes, sir.
So therefore, A by sine A is equal to C by sine C. Now look at these two equations. B by sine B is equal to C by sine C, and A by sine A is equal to C by sine C. So all three are equal. So therefore we can write A by sine A is equal to B by sine B is equal to C by sine C.
Okay.
Did you get this?
Yes.
So this is a very important property of any triangle, that any side, A is any side divided by sine of the opposite angle, which is sine A, is equal to other side divided by sine of opposite angle, and that is equal to the third side divided by the sine of the third angle, which is opposite, right? This is called the sine rule,
Okay.
and you will need this over and over and over again when you are dealing with triangles. This is one of the rules that you will need. Okay?
Okay.
Is it clear? I'll take a pause here. Is it clear? This is very crucial. Is it clear?
Yes, it is.
Yes, sir.
Do you have any questions, any doubts on this concept?
No.
Okay.
So, sir, sine is basically the opposite over the hypotenuse.
Yes. Sine of any angle
Okay.
in a right angle triangle is the opposite side over the hypotenuse. Okay. Good that you reminded me. I will tell you a very simple alliteration to remember this. And it goes like this. Some people have curly brown hair turning permanently black. Now, what does this mean? This is an alliteration, and look at the first letters. Some, S, P, and H. S stands for sine, is equal to perpendicular by hypotenuse, or opposite by hypotenuse, whatever you call it. Cos, C is cos, base by hypotenuse. T is tan, perpendicular by base. Right?
Yes, sir.
Yeah.
So this is a nice way to remember this. Some people have curly brown hair turning permanently black. So whenever you get confused, just recollect this, and you'll soon get what is sine, what is cos, what is tan.
Okay.
Okay.
Yes, sir.
Okay.
Another way, which I learned it, which I find easier,
Yeah.
is SOH, so ka toa. So SOH,
Yeah.
COA,
BOA,
COA.
COA. Sorry.
Yeah. So ka toa.
So
TOA. So it's
TOA.
SOH, CAH, TOA. I misspoke. Sorry.
CAH. Okay.
Yes.
Sokatwa.
So ka. Yeah.
Sokatwa. Oh, this is nice. This is nice. Okay, great. So it's good. Either way, you remember this. That's fine. Whichever way, right? Because when we were taught in school, we were taught in terms of base and perpendicular. I know you guys are taught in terms of adjacent side and opposite side. So this is also very, very good. Okay.
Yes, sir.
So okay. So now we got a very important relationship, which is A by sine A is equal to B by sine B is equal to C by sine C. Now, what does this mean for us?
Um, that means that they all are. The angle is proportional to the side.
Correct. So, in other words, I can look at any two of them and I can say that if I know the two angles and one side, I can find out this side, right?
Yes,
Let's say
sir.
I'm given angle A, angle B, and side B. So I can find out side A. I can find out
Yes,
side A,
sir.
right?
Yes.
Side C and angle C.
Yes, because if you know A and that relationship, and you've got one of the other sides, you can find it out.
But I need to know C, angle C, in order to find out side C.
Right. So if you've got the angles, you can add them together and then subtract it from 180.
Yes, that's the first rule. So if I'm
Hmm.
given any two angles, I can find out the third angle. So third angle would be 180 minus A plus B. So this is known. So therefore C is known. So which means if I am given two sides, now which two sides? Sorry, two angles, which two angles and which side? So this is A, B and C. This is A, B and C. So I'm given angle A. I'm given angle A, which is this angle, angle B, which is this angle, and side B or side A, any of them, right?
Right.
It's the same thing. One of them, I can find out the others,
Right.
right?
Yes, sir.
Or even if I'm given side C, I can do that because since I know angle A and angle B, I also know angle C. So if we are given two angles, it is as good as being given three angles. So if I know any one side, I can find out the other two. Clear?
Yes, sir.
So this is my case one. This is where you have to understand the logic very clearly. So case one, we are given two angles. and one side. Any two angles and any one side. Right? So
Right.
then we will be able to find out the rest. Rest can be calculated. Clear?
Yes, sir.
Yes.
What if we are given only two angles? Can we calculate the others?
Given only two angles and no sides?
No sides.
No, I do not think we can.
No, you can't. Because logically, see, the triangle can be like this or like this. Exactly same angle, similar triangles. So two
Right.
angles given means you know the third angle. So it can happen here also. But unless you are given at least one side, you cannot find out the rest. Clear?
Yes, sir.
Yes.
So we need at least one side. Okay. Case 2. We are given two sides and one angle. Can we find out the rest?
Yes.
Two sides and one angle. Can we find out the rest?
Yes, sir.
Yes.
Are you sure?
If you find one angle and one side, you are able to figure out their ratio, A to sine A, and then you can find the other angle using that same ratio applied to that side,
Not always.
and find the angle B,
Not always.
and using.
Not
Oh,
always.
okay.
I give you the side A and side B and angle C.
Right.
Combination. AB, side AB and angle C. Can you find out the rest? The answer is no. Not by this route. You can, but not by this route. We'll need a
Okay.
different technique, a different rule for that. We'll come to that, but not by this route. Okay. Now, so basically, if you look at the triangle again, ABC, ABC. So, if I am given A and B and the angle C, that is the included angle,
Then yes,
then
you
I
can.
cannot use this rule. Clear?
Okay.
Oh, okay. Yes.
Clear.
Yes.
What if I am given two sides and any other angle which is not included? So A and B and sine A. Then I can find out the rest. Right?
Okay.
Clear?
Yes.
Think about it.
Yes.
Yes, sir.
If I am given this combination A, B and A, then I'll be able to calculate B. Once I calculate B, A and B is known, so I can calculate C, and therefore I can calculate C, small c.
Yes, sir.
So given two sides and one angle, not the included angle. Clear?
Yes.
Yes, sir.
Then the rest can be calculated. Okay?
Okay.
Yes, sir.
What if I'm given all three sides A, B and C? I'm given all sides, no angles. can I calculate?
No.
Rita,
No,
can I
you
calculate?
cannot. No,
No,
I do
sir.
not think so.
No,
No.
you can. Let me show you how. So I am given A, B, and C, right? So I know A by sine A is equal to B by sine B is equal to C by sine C, right?
Yes,
Right.
sir.
In place of C, can I write 180 minus A plus B?
Yes, you can.
Can I write this?
Yes.
Yes, sir.
So this becomes equal to C over sine of 180 minus A plus B, correct? So
Yes.
sine of 180 minus x is equal to sine x. So
Yes, sir.
this needs a little bit of trigonometry. I mean, it's not so straightforward, but it can be done. I'm just showing you the way. Okay. So this is
Okay.
equal to C by sine of A plus B, right? I'm just showing it. Okay.
Right.
Don't worry about this. I'll show you a much easier technique to find out if this combination is given. Okay. But it can be done from here. That's what I'm trying to show. Okay. So therefore,
Yes, sir.
A by B is equal to sine A by sine B. This is one equation. I'm trying to find out A and B. So this is one equation between A and B. The other equation is A by C is equal to sine A by sine of A plus B means sine A cos B plus cos A sine B. Now from these two equations we can find out the value of A and B, but it's cumbersome. Okay, but the answer to
Yes,
the
sir.
question is yes, it can be done. Okay, I'll not get into this because this is not how we do it when the combination is given. We use another rule. Okay.
Okay.
Okay. So case. So there are two cases where we can find out the rest of the sides and angles if three of them are given. Clear with this?
Yes.
Yes, sir.
Okay. The last thing that I'm going to show you today is there is another important, very important application of this rule, which is to find out the area of the triangle. Area of the triangle, right? So what is area
Yes.
of triangle ABC? Half
BC
base into height,
times. Right.
right? Sorry, this is A. BC is A. Half A into H, right?
Right.
Now what is H? So we know sine C is equal to H, sorry, B over H over B. Sine C
Mm.
is H over B, correct?
Yes.
Yes, sir.
H can be written as B sine C, correct?
Yes.
So triangle ABC, area of triangle ABC is half A. In place of H, I write B sine C.
Okay.
Yes, sir.
What does this mean? This means that there are two sides which are given and the included angle is given. Okay.
Okay.
So mind you, in your exam, there might be very tricky questions around this. What happens is sometimes they will give you, very often they'll give you two sides and the included angle. They'll ask you to find out the rest of it. Okay. And they'll also ask you to find out the area of the triangle. Now, area of the triangle is very easy. If you are given the any two sides and the included angle, two sides and included angle. If this combination is given, then area of the triangle is half into product of the sides into sine of included angle. Right? And by similar logic, we can show that area can be half AB sine C, which can be equal to half BC sine A, which can be equal to half CA sine B. All are included angle and side combinations. Clear?
Yes, sir.
Yes.
Kushal, any doubts?
No.
Okay.
It makes sense.
Okay. So I will go a little slow on this because this is a concept which once you understand this concept, you'll be able to crack any problem on triangles, no matter how tough it is. This is one of the rules for that. I will talk about the other rule tomorrow.
Okay, sir.
Okay. So I hope whatever we covered today is clear to you. This is
Yes, sir.
this is the fundamental, and the reason why I don't recommend by hearting formulas or going with formulas is because all of these can be derived as I showed you, okay, without remembering these formulas. So I don't need to remember this at all. I can just draw a triangle, drop a perpendicular, and check out how it works.
Okay.
Make sense?
Yes, sir.
So all I need to do is to understand the basic principles. Here also, I started off from the basic principle, half into base into height. This is the idea of a triangle. So from there, I can derive anything that I want.
Yes, sir.
Okay?
Yes, sir.
So we'll take a pause here. What I'm going to do is, since we have covered a little bit of the coordinate part, so I will give you some exercise to do on Quizstar. I'll send you the link, and once you log in, you will be able to see the tests that would be there.
Okay.
Okay? So I'll set it up today and try and send you by evening or tomorrow morning latest.
Sure.
Okay? So that's all for today. We'll meet tomorrow again. And Prisha, let me know what time works for you. I'm
Yes,
fine
sir.
with anything.
Okay, sir.
Okay? Okay, guys.
Okay.
Yes.
Have a good evening, good day, and we talk again tomorrow.
Yes.
Yes, sir. Thank you.
You're welcome.
Thank you.
Thanks, Kushal. Have a nice evening.
You too.